Hi, my name is Pat Brannick, amateur radio call sign N2BZD. Welcome to my 7 MHz Colpitts oscillator design using a crystal. Note the telltale Colpitts voltage divider C1 to C2. The ratio I found to work best for stability was approximately 0.4 or 0.41, which is accomplished with C1 to C2 of 162 to 388 picofarads. The DC voltage is set by two resistors, R1 and R2, both 33k ohms. VCC can be between 9 to 12 volts, although with the 2N3904 I have had it oscillate at as low as 4 volts. Using a 50 ohm dummy load. For C2, I'm using two capacitors in parallel to equal 388 picofarad. The goal there is to minimize stray inductance and resistance by having it cancel out in the product over sum rule. You note I did a proto board design. Some people may have exception to it, but I find below 10 megahertz, the proto board design seems to work just fine and makes for easy switching out of components. Of course, when you're using leaded components rather than chip capacitors, you often find it necessary to put a few capacitors in parallel to minimize parasitic inductance or resistance. With that, let's energize the oscillator. We'll check out the frequency on a Kenwood TS440 transceiver. Note we have a frequency of 7.03132, 7.0132. Our crystal is for 7.014. I've checked that crystal in a known Pierce oscillator and it does resonate at that frequency. Varied voltage and other parameters, but we still seem to get a good oscillation on 7.0132. Apparently the bipolar stray capacitance at this frequency is significant enough to pull the frequency of oscillation down slightly. And thank you for watching this video.